All right. OK. I guess first I just wanted to say thanks so much for having me. It's been really cool going around Singapore. It's a very beautiful country, and I'm really stoked to be here. I got some tips from Charlie and Donnie for this conversation. So if this completely bombs, it's on them. They've definitely had some experience. And I basically, surprise, surprise, I'm an iOS developer at an iOS conference. I know that's pretty crazy. I build right now a virtual pets app called Pixel Pals. It's a fun little app where you can adopt kind of pals and put them across your iOS device. I say that not as a promotion, but just kind of set the scene for the rest of the conversation. So you can imagine you can adopt like a fox or an axolotl or a cat or a T-Rex or anything, and they kind of live on your home screen, and you can feed them, play with them, care for them, and kind of watch them grow over the months. And it's a fun little thing. It's been a different app than I've built in the past, but it's been a lot of fun. And one day, though, I got pretty much the worst email you can get as someone building a virtual pets app. And I don't know if everyone can see this, but it's this user basically saying, "Where's Fuzzy?" Fuzzy was unfortunately their cute little cat that they had for months and cared for, and then one day they just woke up and it was completely gone. Again, it's not a real cat, but it's still very emotionally troubling. And it was hard for them, but it was honestly, I was reading this and I was like, God, that really ruined my day. Like, that sucks. And I was really racking my brain trying to figure out what could have caused this. Like, the data itself isn't anything crazy. It's like basically a small, simple Swift struct that I'm storing, and it's no crazy custom storage solution or anything. I'm just saving it to UserDefaults, which is a very tried and true Apple framework over decades, if anything. So I was genuinely really confused what could be causing this. I was thinking, is it like a cloud sync overwrite or something that's happening? And I was looking through the logs, and it wasn't that. I was trying to think, maybe there's some data corruption where it's trying to like decode it back, and it has no idea what's going on, so it kind of just resets. Wasn't that. And I was seeing, maybe like the backing plist file for UserDefaults is getting too big, and iOS has to save disk space, and it kind of purges it. Wasn't that either. So I'm looking through the logs, and it's really weird because it's almost like you just have it at one point, the data. The data's there, the data's there, the data's there, and then just all of a sudden, the data is completely gone, and it effectively resets to the starter data. It was almost like one of those freak accidents you see where like a cosmic ray hits someone's phone and a bit flips from a 1 to a 0, and suddenly all the data's gone. But a few more emails rolled in from users, and I was starting to suspect, just from it happening to a few people, that this wasn't cosmic rays. Something was going weird. And I was looking through the logs, and nothing was very clear as to what could be causing it. Until one day, a user, the best kind of user, emails me and says, "Hey, I have reproduction steps for this bug." And it turned out, if you launched a live activity, weirdly enough, and then you rebooted your iOS device, and then right after the device rebooted, you would open the app back up, and it would basically be in like a fresh state, like you just installed the app, like all your data was gone. And it was super weird. And I tried this, and sure enough, yeah, that worked every time for me. That reproduced the bug perfectly. No idea how I hadn't tried that before, but at least I had something. Like, I'm sure you've all dealt with a bug where as soon as you start being able to reproduce it, like, you know you're onto something. So I'm looking through the logs at this point now that I've been able to reproduce it, and there's still nothing. It's basically the same thing where it's there, and then just suddenly it's gone. And so I'm like, OK, I can reproduce it reliably, like each time. So it's definitely not cosmic rays or something terrible. So what could it be? And then it kind of hit me. I knew there was this keychain API where you can basically say this item I'm looking at is encrypted until the user first unlocks their phone. And I was like, OK, there's a kind of a similar analog with file storage where you can say this file is encrypted on the device until the user first unlocks their device. And I was thinking maybe the default on iOS for my log file is like locked. So when this event happens, my app's trying to read the log file back and then write to it, but it's unavailable. So it's basically like this blind spot in my security camera, so it's not getting added to the logs. So I look, and sure enough, yeah, that is the case. iOS, by default, locks these files until the user first unlocks their device. So you can kind of overwrite that by if you just set the protection type. to none. So you obviously want to do this with carefulness, because you don't want to do this for a file that stores something important like passwords or API tokens, for instance. But for something as simple as just some simple log files, it works really well and increases the scope of where you're able to log. So once I did that, I was able to start to see, OK, now I'm actually seeing what's going on with this bug. The user would restart the device. iOS would basically see, OK, they had a live activity running before. So as soon as that lock screen springs back to life, I want to restore their state so that live activity shows up immediately. So as soon as that screen flashes to life, iOS would wake up my app and say, give me all the data. But weirdly, I would go looking through the logs, and I would see that UserDefaults would just suddenly return nil for data that I knew was there pre-reboot. And basically what my app would do is go, oh, OK, so there's no data in UserDefaults. That means the user just installed this app. So let me get them up and started with some starter data, just so they kind of have an idea what the app's doing. And then the user would inevitably kind of click around in confusion, going like, what's going on? Why is all my data gone? And they do something that would ultimately store stuff back to UserDefaults. So that bad data, that nil data that UserDefaults gave would then overwrite the data that they did have. And then you'd basically have all their data gone. So I was like, OK, I'm making some progress here. I still have no idea why UserDefaults is randomly returning nil. Worse, like as soon as the user unlocked their device, all the data would be available again, presuming you hadn't overwrote it. It was just for that brief period where the device was still locked. And again, I was really confused. Like, I'm not doing anything with encryption here or super secure data. It's some guy's cat named Stanley or Fuzzy. Like, this isn't super serious encrypted data, so I didn't think it was that. And then naturally, as soon as you start encountering a bug and you start knowing more about it, you start to magically find some posts on Stack Overflow where people are encountering this. And it turns out it was a thing people have dealt with for like a few years now, where they would just randomly try to access UserDefaults, and the data would be gone. And it was really strange, but now I'm seeing that other people are having it. So you basically have this issue where before the phone was unlocked, or while the phone is locked, you would get nil back. And then the second the phone is locked, everything would spring to life. So I was like, OK, we're starting to make some progress here. And the thing to keep in mind here is that UserDefaults is a really old API. From what I was able to look up, it's like 1994. So that means UserDefaults was released, actually back then it was NS UserDefaults. It was released closer to the moon landing than modern day. So it's very old. And I mean, that's true for any of you, older than 1996. We're all getting pretty old. So it's an old API, and it hasn't necessarily done an amazing job of keeping up with the times. Like, I've been an iOS developer since like 2013, I want to say. And over that period, UserDefaults has like barely been touched. So there's a lot of stuff that's changed in iOS over the years where this API hasn't necessarily kept up with those changes. And one of them, as we discussed, is this, like with my log file, is that it's initially created by default in this lock state. And I don't know if that's purposeful or Apple wasn't aware that that's the case now. But it was basically sort of what seems to be catching UserDefaults. And it doesn't necessarily make a lot of sense, because you have this API Apple recommends you use, this keychain, if you're actually storing properly secure data, like passwords and API tokens and whatnot. And UserDefaults is kind of this catch-all everything API endpoint for everything else, like the stuff that you don't necessarily care so much about. Like it's just mostly for like preferences and small data. So it didn't make a lot of sense to me that this was getting caught up in this. And especially where even if you can make the argument that UserDefaults should be locked by default, the fact that it has no insight into its like state as a developer was really confusing to me. Like you could do something simple if you were Apple, where you could say like, let's make UserDefaults the standard UserDefaults or our suite names or whatever we create. Let's make it optional, because it might not. If the device is locked, we could say we'll return nil in those cases. So you can kind of do a check to see like, should I even be trusting UserDefaults now? And even if that's too complicated, we could say, like, let's have a static variable on UserDefaults that say, like, is this data even available right now? And we can at least check that. But there's nothing. Like, this will just silently fail. You'll have no insight, no crash logs, no warnings, no error you can catch. It just kind of silently returns nil with no insight. The one thing we do kind of have that is nice is we have this instance property on UI application where we can say, is protected data available? And it'll basically return no if the device is still locked, which is handy in a way. But like everything, there's a catch where it's only available in the main app, which again would have been great 10 years ago, but now apps have all these different extensions you can run. You can have content blockers, you can have widgets, you can have live activities, you can have all these other aspects where you can access user defaults, but you have no access to this property since this code isn't executing in the main app. So we're kind of stuck there as well. And worse, even if you did have that property, there's lots of opportunities like lock screen widgets where you might want to say, like, hey, user defaults, what is the current pixel pal they have selected? And the device very well may be locked at that point. That's kind of the point. Your phone's locked. You still want to have stuff like lock screen widgets. So it doesn't even necessarily make sense that even if you can check it, having the state be that, OK, you can't access anything isn't very helpful because you still would need to access it in those cases. And this is obviously what happens if you try to access it in an app extension. You just get this property is not available in this context. So that kind of shows us why it's happening. But it's also important to mention that this isn't something that just happens with live activities. Like, that was just a very easy way to trigger the bug. But this can happen very easily just about any app. And the reason for that is, I don't know if you folks remember, like around iOS 13 at WWDC, Apple came out and said, we're doing this really cool thing where with no work on your end required, all your apps are going to launch like twice as quick. And this was really cool, and it is really cool. And it turns out the way they were able to accomplish that was this process called application pre-warming. And it basically meant that Apple would try to use some heuristics to see, like, oh, so-and-so opens the news app every morning at 8:30. So maybe half an hour before, what iOS will do is they'll pre-launch that app and kind of get it warmed up. And then when you actually physically launch it yourself, it'll launch much quicker because all of the kind of initial startup stuff was done like half an hour earlier, and the app's kind of just waiting to be launched. And that's really cool, but the unfortunate side effect is it really challenges your preconceived notions about how an app launch occurs. Like, now it's not necessarily true that the app launched from a user tapping on it and it's springing to life. It could have launched half an hour ago when the user's device was still locked, charging for the night or something like that. Which, again, Apple did do a good job, sort of documenting. They would say, like, just be wary that, like, your UI application delegate's initializer can be executed, which was fine. But it turns out in reality, the documentation wasn't necessarily accurate insofar as there was a lot of, your app can actually do a lot in this pre-warming stage versus what the documentation can say it can do. For instance, like, it will go right through your application did finish launching. So if you're doing anything in there where you're saying, I'm assuming anything about the app state, like you're assuming user defaults is available in your application did finish launching, or even any of the view controllers that get launched as part of your application did finish launching, any kind of preconceived notions that you might have about what state your app is in, is it in the foreground, is the device unlocked, any of those might suddenly be completely wrong, and your app is actually launching well before when you think it might be. So I was having this instance where all these view controllers I kind of assumed would be launched in the foreground when the device was in a good state were suddenly not at all. So you can imagine, like, how can this manifest in a negative way? Like, what does this actually mean in practice? Or is this kind of just fear-mongering, I guess? So say you're an app like Duolingo, where you're a language learning app, and you want to kind of incentivize your users to open the app every single day. And to do so, you maybe give them some coins or something to maintain their streak. And you say, you know what, after 365 days, a full year of opening the app in a row, we will give you kind of like a mega reward for keeping up that consistency. So your users are diligent, they're opening the app every day, and they're really excited for this 1 year period to occur. And you can imagine in code, you might implement it something like this, where in the application did finish launching method, you check if it's a new day, and if so, you grab the current streak from user defaults, you increment it by 1, and then you save it back. If it happens to be 365 days in a row, you give them a big old reward. Pretty straightforward, simple code. So what can happen in this case is it's possible that this application did finish launching code, as of a few years ago, could have occurred way before the user actually physically launched the app. So it might have happened while the app and the phone was still completely locked. And you can kind of get this code path where you say, OK, user defaults, give me that streak. It goes I have no idea what streak you're talking about, 0, I guess. You increment that 0 to a 1, and then you save that back. And now you've completely overwrote the user's data, their streak that they had. The 365-day streak is not at all happening. And instead of that user waking up that morning really excited to get this mega streak, they're going to wake up, get congratulated on having a 1-day streak. They're probably going to delete your app, cry a little, and they're never going to learn Mandarin. And it's a bad situation for everybody. So we have this situation with user defaults where it's usually trustworthy isn't necessarily the best slogan for an app or a framework that you're trusting to store your data. So we're kind of looking for something a little different here. But if you don't want to go whole hog and completely replace user defaults, there is some stuff you can do. So you could like override or write a custom setter where you can basically say like, can I even trust the data I'm looking at? If the phone is still locked, basically just return early and abort everything. Don't trust the data, run. And this will protect you against a lot of stuff. And it's a good first step that I'd recommend. If you do have some preconceived notions about user defaults and how it works, I would maybe explore this at the very least. Again, the tricky thing here, though, is if you do this in your widget, like this code won't compile because is protected data available is not even available in a widget context. What you can do, again, really getting into the weeds here, is you can do a bit of a hack by basically saying, like, let's write a file to protected storage, and then see if we can read it back. And if we get thrown an error, we can probably assume that the device is locked. Again, kind of a janky way to do it, but it's surprisingly fast on modern devices, so it's not too bad, provided you don't do it too frequently. And then, weirdly enough, Notification Center will emit protected data did become available notification, even in your widget, once it does become available. So at that point, and in your main app, you can say, OK, now I'll start trusting user defaults again. But this isn't an ideal solution because while you're not writing bad data, you could still have like bad data sitting around in memory from before when you read it. And then you could erroneously go to a settings screen or something and then still save that data back. So this still isn't a great solution. So there was a quote I heard where if you can't get bad data, you can't write bad data. And that's kind of what we want to approach this with as a mindset. So we'll have the keychain for our secure locked thing. So if we're storing passwords or API tokens or like a secret cookie recipe or something, we want to store that somewhere secure and somewhere purpose-built for encryption, like the iOS keychain. But for non-locked stuff, like how many apples your Fox ate, a user's like preferred font size, or how many times they've launched the app, this stuff isn't necessarily having a security component. So we'll try to figure out a new system that can replace user defaults where we can store this. An easy approach, obviously, would just be let's just throw it in a text file somewhere. We can, similar to the log file, we can say like, no file protection on this. Let's just make it available all the time, and we can write a value to it. This totally works in theory. It's just a little cumbersome. Like you can imagine having a file for every single property you have isn't necessarily the most elegant. And beyond this, user defaults has a lot of, despite me ragging on it a little bit, it does have a lot of really nice functionality built in. You can see many of them. Like it's thread safe, so you can ensure if you're trying to write it across multiple threads, it handles that properly. You can access it all in extensions. If you try to use it across multiple processes at the same time, it handles that properly. But there's other stuff we can do, like giving it a modern API rather than one from 1994, that I think would go a long way to like a modern-day Swift implementation that I think would make it really nice. So I think we can take user defaults, not only fix some of the holes we've encountered with it, but we can kind of take it a step into the modern age and make it even nicer. The first issue we have to encounter, though, is this access and extensions. So if we were just to write our data to our documents directory, one thing to keep in mind is every single aspect of your app in extensions versus the main app versus every single extension, they're all sandboxed separately. So they all get their own documents directory. So you'd be swimming in 17 different documents directories depending on where you save the data to. And this isn't particularly helpful because if you're trying to see like how many apples has my fox eaten, and your widget says 7 and your host app says 37, that's not necessarily great. So what we can do, similar to user defaults, is we can enable app groups. So we can say, I want to have an app group, so all of my apps, including all of my extensions, kind of can share the same data. And again, you can use this in user defaults as well through a suite name. And then all of your user defaults will be saved across your app extensions as well. But not only is this available to user defaults, we can also use it for file storage as well. So I can grab, for instance, some data and store it in the container for the whole app group rather than the documents directory, which is really handy. And that also brings us into our second aspect that we want to handle. User defaults does a great job of saying, like, if the app crashes while you're trying to save data to user defaults, the whole thing doesn't explode. And we can implement this pretty easily in our own system, too, by just using atomic writing, which sounds like a really nebulous, fancy concept. But it's basically just saying each operation is like this distinct, indivisible operation, and it either all succeeds or it all fails. And it does that really simply and really cleverly by just basically, when you're writing a new file, say you're writing this like 25 megabyte new file to overwrite your existing data. If that failed at like the 12 megabyte point, you'd kind of have like a half data blob where if you tried to decode that, it wouldn't work very well. So atomic writing handles that by it'll take that 25 megabytes and write it to a whole new file. And only once it's done will it rename that file to the old file's name and delete the old file. So it really only, if it crashes halfway through, that new file will just kind of get ignored, and the old file will still exist. So you have this nice aspect of where your data is much more secure than if you kind of just had a partial write going. Next up, we also have to handle threading, which is, of course, every developer's bane of their existence. There's lots of ways to handle this. I'm just going to handle it in dispatch queues because I wrote these slides before I listened to Donnie's talk. And it's really simple where with a dispatch queue, it's basically just like a traffic guard where you can say, I want to make sure this data that I'm accessing, multiple people can't try to get into this intersection at once. So you basically ask the traffic guard, or the dispatch queue in this case, can I access this? And if so, it'll let you in, and you can access it within the block. But if you can't access it, it'll kind of just block and make you wait a little second until whoever is already accessing it finishes it. So you won't get a situation where you only have one person touching the data at any point. And this is really nice for threading, because if you have networking code that's accessing the data, and then you have UI code that's trying to save it, if they both try to write to that data at the same point, you'll get this nice situation where both of them will have to wait their turn, rather than it kind of both trying to attack the data at once, and you get in kind of an indeterminate state. That being said, threading kind of has an evil older sibling that not a lot of people talk about, which is cross-process safety. So you can get into a situation where you have your main app might have threading implemented perfectly, but in a different process where your widget's running, it might have that same code. And you can have a situation where you have the two traffic guards, and they both say, go on through, one per process. So your main app is saying, everything's fine, touch that data. Your widget's saying, everything's fine, and touch that data, because they're not aware of each other. And you get the situation where you're basically back to the same threading situation where two things are trying to touch the data at the same point, and we don't want that. The way we can handle that is, thankfully, iOS has a really handy API that I wasn't aware of prior to this, called NS File Coordinator, where it's basically just almost like a city-level traffic guard, where it says, you ask NS File Coordinator for access, and it coordinates across multiple processes, provided they're all using this API, that say, OK, is any other process touching this? Not only any other thread, but it's any other process touching this. And if so, it'll make you wait until that file is freed up and no one's touching it anymore. And this is really handy because now you can trust that even if your widget's writing the data, your main app can be trying to write the data at the same time, and then that'll be handled and queued up properly without things kind of stepping over each other, which is a really nice API, and it was a lot simpler to implement than I thought. But we're still at this issue where we still haven't solved the issue of every single data piece would have its own file at this point, and that's not very handy. That also wouldn't be very performant. We want an API that's more akin to UserDefaults, where it's more of like a key value dictionary, something where you can store all of it in kind of the same place. And one thing, this is convenient in UserDefaults, but one thing that's I've always disliked, especially since the advent of Swift and UserDefaults, is that it's very stringly typed, which through Paul's talk we've seen can have a lot of little subtle bugs that introduce into your app. Like I'm sure I'm not the only one that you've typoed like a defaults key wrong, and you get this really subtle bug where you're like, I'm not sure what's going on here. I don't know why, and then you see, oh, I forgot a U. Let me fix that, and then suddenly everything's working again. I was thinking if we're kind of reimagining user defaults, let's kind of make this more Swift-esque and kind of address this in a modern way. And we can do that in a pretty simple way by just having like a protocol for our key, where we can say it'll be implemented as a key, but implemented as an enum, and you only define the key once. And then from then on, we can just refer to it really easily. And if I was to say, spell that as lanches instead of launches, that would be a compiler error that would be caught immediately. Like, I wouldn't be scratching my head at what's going on. It would just throw an error, and I could handle that right away. So that, in and of itself, I think is a really nice improvement over user defaults right away. And implementing that is pretty easy if we're just storing data. But one issue is kind of like, how do we store the data? One aspect of user defaults that I also don't like is that it's very limited in the data types it supports. That you can do like a string, a Boolean, an integer, and anything beyond that is just you have to store it as data, which is kind of inconvenient in this modern day Swift where we have more advanced types and we have a lot more flexibility there. So I don't want to say like we can just store anything in there because that doesn't really represent what we're storing. Like you could throw in a UI scroll view into this function and it would technically be fine, even though there's no way to take a UI scroll view and convert it into data. Thankfully, Swift does have a really nice way to say this data is encodable and decodable, which again we saw yesterday, which is just the codable type. So we can say we'll store a codable value at a certain key, and that's the basis for our API. Internally, we can handle everything for decoding and encoding that. But from the user's call site, it's really simple. As long as you have a Swift type that conforms to codable, they can pass it directly into our API, and we'll handle everything for them, which is a lot nicer than kind of having to convert everything to data at the call site and then hand that into user defaults. The retrieval side is a little different, and generics can kind of be scary sometimes. But in this case, it's really not that bad. We're basically just saying we want to retrieve a certain type. But rather than caring about what the object itself is, we just care about the object's type. And that's what we're using the generics for. And this allows us to basically implement it by saying we'll grab that value, that key rather, from our dictionary. And then we can use the type the user passed in to decode it as that type and then just return that. And it makes for a really nice call site for when we use the API because we're just saying, hey, we want a user. And it's available at this key. And our internal function will handle fetching that and then decoding it properly and returning nil if there's nothing available there. Storing is also even easier because we don't need them to pass in the data type. As long as it's a codable type, we'll handle the rest. We'll encode that into data and store that in our storage. One issue we're hitting, though, and you might hit, is that we're still storing everything and touching the disk a lot in our access. We don't have anything living in memory. So on modern devices, this is surprisingly quick and might not be something you have to worry about. But if you have like 10,000 items in a scroll view, and every single one of those is hitting the disk to read the data, that will probably start to chug a little bit. So what we can do is just kind of have a dictionary representation of the data that we keep in memory, almost as like a cache. And attach that back. And this will work a lot nicer because instead of hitting the disk every time, we can just hit a memory store directly. And the implementation is really easy as well. Instead of touching the disk at all when we're retrieving data, we just ask for the array and return from that. Only once we're actually storing and changing the data on the disk is that when we actually have to touch it. And we'll just update our in-memory dictionary store and then update the item on the disk as well. Naturally, there's always a drawback to something, and the issue here is if we are doing app extensions and we have something like a widget, we can get an issue where the widget updates its in-memory store, but since we're not retrieving everything from the disk every time now, we're only touching the memory store, when the main app tries to retrieve data again, it might not be aware that the widget just changed something. So we kind of have this issue where the widget and the main app can kind of get out of sync with what data they're storing. Like everything I've discovered in this, iOS has an API for that. There's a really cool API that's not necessarily named super well on dispatch source that, again, looks complicated, but it's actually deceptively simple, where you basically you give it a path on the disk, typically a folder, and you can say, anytime anything in this folder changes, just let me know, and it'll execute inside this block. And that way you can say, OK, something in this folder changed. You can make the only thing in that folder your file. And you can say, OK, something in that folder changed, so I'm just going to fetch my in-memory store. So that way, if the widget were to change something, your app can detect that. Your host app can detect that and then update its in-memory store, so you never get out of sync. And that's, again, really handy API that I wasn't aware of and was actually very simple to implement. So at this point, we have a very nice system for accessing and retrieving data that's very similar to UserDefaults. But we're still short in one area, which is, if you're unfamiliar, there's this property called app storage on UserDefaults, which lets it integrate super nicely with SwiftUI, where you can basically, it's kind of like a supercharged state variable, where you can say the key that corresponds in UserDefaults to your variable, and then you give it a default value just in case it's not there. And then, like a state variable, it'll be reflected in your UI whenever it changes. And if your UI changes in any way, like for instance, if you have it in a text field, any change you make to that variable will instantly be written back to UserDefaults. And this is honestly pretty spiffy. So I kind of wanted something like that for our library as well. It looks a little scary, but it just uses property wrappers. And again, this looks like a lot, but property wrappers aren't that bad. Like 90% of this is just boilerplate. The real meat and potatoes is just this part, where SwiftUI is basically saying, what happens when I get the value and what happens when I write the value? And we're just basically mapping that to our internal methods. So when it asks for something, we're just retrieving it from our storage. And we're setting something, we're just setting it in our storage. And this works really well to get a very easy implementation that is incredibly similar to that app storage. So we can say, we'll just call ours tiny storage item. We specify the key as well as where our storage instance is. And then we basically have the same implementation at the call site as app storage, except we get one thing cooler where app storage has this annoying implementation, I'm not even sure why, where you can't actually access collections. So you could store like your favorite ice cream in app storage and get that back. But if you had an array in UserDefaults instead, it's not necessarily nearly as nice to access that. But with ours, we can totally do that. We can store a set, an array, a dictionary, or anything, and easily access those in SwiftUI and have that right back to disk and update dynamically in our UI. So with that, I think we've created a half-decent replacement for UserDefaults that kind of addresses this kind of spooky little side effect that UserDefaults can have, where our data is not necessarily reliably accessible. And when that occurs, it's not very clear to the developer when it happens. Like there's no API that we can really subscribe to that lets us know when that happens. So if anything you get from this, I would say challenge your preconceptions about how UserDefaults works and how it might be accessible, because you can quite easily end up in a situation where there's some data loss. And using something like this, where it's basically file storage with some sparkly additions on top of it, you can get a lot of the niceties of UserDefaults without a lot more of the work. And I ended up tidying this up a little bit, and I uploaded it to GitHub for free. So if any of this is interesting to you, you can kind of see I have a library here. It's still beta-y, but it talks about everything in this presentation and makes it easily accessible, kind of in a nice little wrapped-up package. And that's basically it. If you take anything from this talk, and I can save you a few hours, days, or weeks of grueling debugging and sad user emails by just saying, watch out what UserDefaults is doing and make sure you're not assuming anything when you shouldn't be. And yeah, hopefully that addresses some things that you can learn about UserDefaults. And if anybody has any questions, or if I'm sure I've said something over the course of this half hour that wasn't very clear, I'm more than happy to answer any questions in the minute and 30 seconds we have left.